In this example, we're asked to find the volume of the solid generated by revolving the first quadrant region bounded by the curve y equals x cubed plus 3 and x equals 2 about the y-axis. So if we put the line x equals 2 on our graph, that's this line, and then we draw our rectangle. If we start with a dy rectangle, we should notice as that rectangle moves, the left is on the curve, the right is on x equals 2, until we get here. At this point, now the top or left, bottom or left of the rectangle is on the y-axis, but the top would be on x equals 2. So that particular rectangle is not going to work. If we delete that one or rotate it to be a dx rectangle, now we should see as it moves from left to right, the top is on the curve, the bottom is on the x-axis, and that's true for the entire region we're looking at. So that's the rectangle we're going to want to use. Our axis of rotation is the y-axis. So we're rotating around this way. That means we're parallel to our axis of rotation, which means we're using the shell method. To use the shell method, we need a radius, a height, and a thickness. We have a dx rectangle. That's our thickness. The distance from the axis of rotation to our rectangle is x. That's the radius. And the height means the height of the rectangle. So the top curve minus the bottom. In this case, the bottom is 0 because it's on an axis. And the top is the function, x cubed plus 3. Now plugging that into the formula, we get 2 pi evaluated from 0 to 2, 0 to 2, of x multiplied by x cubed plus 3 dx. Simplifying then, before we integrate, we get x to the 4 plus 3x dx. Integrating, we leave the constant. X to the 4 becomes x to the 5 over 5. Keep the constant, x becomes x squared over 2. Evaluated between 0 and 2. That gives us 2 pi times 2 to the 5 over 5 plus 3 times 2 squared over 2 minus, plug in 0 for each, gives us 0. And evaluating that gives us 24.8 pi.